Hello, Professor. My name is Fan Xiangyu. Thank you for being here today. I'm excited to share my final project for abw508. The title of my project is Sentiment Analysis and Brand Imaging Prediction Based on Social Media Reviews, a case study of JD.com. In this project, I used customer review data from Jingdong.com to study how people feel about the brand. I also used machine learning tools to predict emotions in the reviews and to explore how these emotions related to JD.com's brand image. I hope this project shows how data science can help companies better understand their customers. This project builds a full system to analyze customer sentiment. The system uses reviews from JD.com, one of the largest e-commerce companies in China. We apply NLP to clean and process the reviews. Then we use 6 different machine learning models to classify the reviews as positive, neutral, or negative. After comparing all models, we find that random forests and XGBots work the best. The main goal is to help JD.com understand customer feedback more clearly. This can support the company in improving customer service, product quality, and its overall reputation. These methods can also help other e-commerce companies improve in customer relationships. The presentation includes 5 key points. Number 1, problem statement. Number 2, research objectives. Number 3, methodology. Number 4, discussion. Number 5, conclusion and feature work. In each part, I will explain what we did and why it matters. I will also share some key findings and lessons we learned during the project. Okay, let's first look at the problems we wanted to solve. Today, customers often share their opinions online. These options are very valuable, but they are also unstructured. People use informal language, emojis, and sometimes they only write a few words. So the first question is, how can we get meaningful emotional information from large amounts of unstructured review text? The second question is, which machine learning model performs best in classifying the emotional tone of Chinese reviews? If we can answer those 2 questions, we can turn online reviews into useful insights. This helps companies like JD.com make better business decisions. To solve these problems, we set 3 research goals. Number 1, compare the performance of 6 machine learning models. We wanted to see which model is best for sentiment classification. Number 2, understand how customer sentiment reflects brand image. We want to see if reviews can show how people feel about JD.com's service and products. Number 3, build a system that automatically classifies reviews into 3 categories: positive, neutral, and negative. This saves time for businesses and allows faster response to customer needs. We also wanted to learn how reviews reflect important factors like delivery experience, product quality, and customer service. We used a real dataset from Cargo, which contained thousands of JD.com customer reviews. Each review has a star rating from 1 to 5. Review tests are written by the customer, a timestamp showing when it was posted. To prepare the data, we removed emojis, special symbols, and HTML text. We used Java, a tool for Chinese word segmentation. We deleted stop words, common words that don't add much meaning, like very or so. We labeled each review based on its star rating. From 1 to 2 stars means negative, 3 stars means neutral, from 4 to 5 stars means positive. Since most reviews very positive, we used the SMOT method that creates data to balance and classes. This helps the model learn better and avoid bias. After cleaning the data, we needed to turn it into numbers for machine learning models to understand. We used two main techniques. TF-RDF. This calculates how important a word is in a document. Words that appear often but carry less meaning, like product, get low size. Words that appears less often but are very important, like damaged, get higher source. Number 2, word to vague. This method looks at how words are used together in context. It helps the model understand the words like excellent and amazing are similar. It gives more meaning to each word based on its environments. Then we split the data into training about 80% and testing about 20% sets. We applied SMOT again to balance the three sentiment classes. We tested 6 well-known machine learning models: logistic regression, naive Bayes, spot-vague machine, k-nearest neighbors, random forest, XGBoost. These models are popular for text classification. Some are easy and fast, like naive Bayes. Others, like XGBoost, are more advanced and work well on large, complex datasets. By comparing these models, we can choose the best for our task. This helps ensure the system is accurate and reliable. We used 3 ways to evaluate the models. Number 1, accuracy measures how many reviews were predicted correctly. Number 2, F1 source compares precision and recall. This is very helpful when the data is imbalanced. Number 3, ROC AOC measures how well the model separates the 3 classes. Why F1 source is very important because many reviews are positives. If a model just say positive every time, it looks like accurate but fail to identify neutral or negative comments. F1 source tells us if the model is doing a fair job across all types. So let's look at the results. Our models had a higher accuracy, over 95%, but we don't only look at accuracy, we must also check F1 source. XGBoost had the highest F1 source, about 0.4114. Logistic regression had the best ROC AOC source, about 0.9056. Naive Bayes and KN didn't perform well. They had trouble with short or unclear reviews. This shows that XGBoost is better for understanding complex patterns in text. It gives more stable results and handles all 3 sentiment types well. So we selected it as the best model for this task. Here's what we learned. We built a full system for cleaning the data to training and testing models. We found that XGBoost performs best for classification reviews sentiment. We saw that online reviews offer rich emotional information about products and services. These insights can help JD.com improve delivery and customer service, track brand imaging in real time, react quickly to customer concerns. But we also found some limitations. Some reviews are too short or unclear. The model only works on China reviews for JD.com. Even with a small class imbalance, it can still affect the results. There are many ways to improve this project. Use deep learning models like BART. This model understands full sentence and hidden meaning better. Combine images and test multimodal language. Product photos plus reviews can give a better picture. Try other platforms like Taobao, Xiaohongshu, and Amazon. This helps test if the system works in different environments. These improvements can make the system smarter, faster, and more helpful for companies. That's the end of my presentation. Thank you so much for listening.